Number 1 says determine how many 6-digit odd numbers. So if it's 6-digit, it can't start with a 0. If it's odd, it has to end in an odd number. And without repetition means we need to box and hold, right? So we need 6 digits. We need 1, 2, 3, 4, 5, 6. It needs to end in an odd number. So we have 1, 3, 5, 7, or 9, which is 5 options. Then we have to box 1 because it says without repetition. Then we go to our first blank and we can have 1 to 9 usually, but we box the 9, right? So it's out. And we can't have 0 because that would make it a what digit? Instead of a 6, it would make it a 5, so we can't use the 0. So we have 1 to 8, which is 8. Then I hold the 8, then I could have 1 to 7, and then this is where the common error lies. What do we have to remember to do? Bring back that 0. So we get an 8. Box to 0, 1 to 7 is 7, and then we go just down by 1. Now, please remember to look at yours. If you don't have the multiplication dots, go back and put them in. They're very, very, very important. If not, it's just a really large number. And what does that get you for an answer? Grady, did you figure it out?
Pardon?
Did you get the answer?
62 or 67,200.
Perfect. All right. Number 2. There are 35 students in John's homeroom class. There are 5 students who take English and biology. And so, did you guys do this one?
Yes.
This isn't even from your unit. This is from next unit. Good job, Lepp. Okay. Let's do it anyway. There are 5 students who take English and biology and 7 students who take neither of these subjects. Oh my goodness, this is a hard one for you guys.
Well, then we got it wrong.
What did you pick?
Yeah, I got way too many.
You got C.
I got C.
D.
What?
D.
I got A. Not A.
It's A.
It's D.
I got
A.
It's D.
D.
Idiots.
D.
Not D. So,
Long talk.
I'm just going to show you what next... Okay. I'm going to show you what next unit is going to look like, because I seem to have thought this was the front. I didn't look at number 2. So what you're going to end up doing in number 2, or in unit 2, is you're going to have Venn diagrams. And what we would do is we'd have our subjects, which would be English and bio. You're getting like a preamble into this, which is going to be literally starting Monday, so welcome. The ones that are in between the 2 classes that are in both, there are 35 in total, so this whole thing. There are 5 students who take English and bio, so they'd be in the middle, and there are 7 that take none, right? So how many are used up? 12. How many are left?
23.
23.
There's also 3 students.
We need to... No, there's 3 more students taking English. So there's 23 that need to split between the 2, right? And English needs to have 3 more. So how can we split it? It would be 10 and 13, wouldn't it?
See, now I know where you're going with this, right?
So bio only would be how many? 10. And as Grady said, I'm always right. Once again.
I said I am.
You said 10. That's what I said. You're always right.
Oh, I thought you
And
said-
once again, you're right. I was backing you.
Thank you.
All right, he's on a roll. He's getting the genius. All right,
Yeah.
ready. Magazine publisher is planning a photographic layout to show how 12 different outfits are possible by combining 1 shirt, 1 jacket, and 1 pair of jeans. This was on the very first diploma ever given in 2013. If 2 different jackets, 2 styles of pants are used for the photographic layout, then the minimum number of shirts to make 12 outfits. So we'd have jackets, pants, shirts have to equal 12. So we have 2 jackets, 2 styles of pants, which is 4. So it's going to be 3.
That was a diploma.
Yep.
You can pass grade 12.
I can.
We hope. We hope. Okay. Next page. Quiet, please.
You don't know my real age.
Guys, not today. A particular school generates student identification ID numbers using the following rules. The first two digits are the last two digits of the year the student started grade 1. So people like want to change them and make them be different things. They are, yeah? You snuck in late. Oh no. That's mask and I have to sanitize and you have to mask and I can handle this one. Such a process. Wonderful process in terms of super happy about. Right? You get to be here, so I'll set that mask up and let you guys be here anyway. We didn't have to be here, so I'm all over it. Some days. Caught on my earring. Okay, let's try again. So, number 4, the first. Okay, so if it's the last two numbers of the year that you started grade 1, does that change for that person? No, it would be whatever year you started grade 1. Okay, so the first two digits are set. They are whatever the heck the year they are. So I have one option and one option because it would be the year. If I started grade 1 in 90, I think it was. Awesome. I would have a 9 and a 0, which would be a 1 and a 1. That would be my only option. You weren't born yet or even thought of, so you're welcome. That's a good one. Now, the third digit indicates student's gender, which in this case is only optional of 1 and 2. It could change, and this was done before all of the changes happened, so I would 100% suggest that this probably isn't going to be how this question would be ever asked again, just so you know. I'm not, it's not in a rude way or anyway, it's just not going to be asked like this again. So this would be, you'd have two options, okay? Then the remaining 4 digits are any whole number from 0 to 9 inclusive without repetition. So you'd have 10 digits here, then they hold a digit, then it would be 9, then it would be 8, then it would be 7, which is A. All right. The 4-digit code, 4-digit security code. Does a digit code, does that mean the first digit can't be a 0? If it's a code? Nope, your digit, the whole code could be zeros, right? So code doesn't make it that that first number can't be 0. So the 4-digit security code for Maureen's old bank account allowed the digits 0 through 9 inclusive, so that includes the 0 and the 9 without repetition. Maureen's new bank card requires a 4-digit security code that consists of the digits 0 through 9 with repetition. Both security codes can start with the 0. This was actually given on the diploma as well. Compared to the 4-digit security code for Maureen's old bank card, there are blank more 4-digit security codes for her new one. So her new one can have repetition. So that would be 10, 10, 10, 10. Her old one can't. So we subtract off 10, 9, 8, 7. What did you get? Sorry? 4960. Do we agree? Given the work, that's a D. Imagine it is. It's not, but it is. Given the word Trinity, how many different arrangements can be made if the vowels must be together? So when we get a word, it's immediately permutation because order matters. Because if not, loop and pool would mean the same thing, and they don't, right? So we have the word Trinity. We need to write it out and stack. So that we stack for a reason. So TRINIPY. Why am I stacking these? Repetition, so I have to remind myself to do what now? Yes, remember to divide those repeating ones. So before I even do this question, I'm immediately going to go brackets, 2 factorial, 2 factorial. Because it doesn't matter what it asks me, I'm going to have to divide by those factorials, right? Now if you went divided by 2 times 2, that would be fine too, because 2 factorial is 2. but you are using the factorial symbol. Because if it was 3 letters, you'd use 3 factorial, which is 6. Okay? So we have, how many letters in Trinity? 7? And we have to keep the vowels together. There are 2 of them. So I'm going to hook them together. So I have 2 options for this one, then 1. Do I care that they're the same? I do not care that they're the same because the 2 factorial on the bottom gets rid of the situations where the I's swap and it doesn't actually make any work. Okay? How many letters do I have left? 5, 4, 3, 2, 1. And I would be done if it says vowels must be together at the front. Did it say that? No, it said together. So then I actually have a whole bunch of spaces that could go. They could stay here, which is one way, or between these 2 letters, which is 2, here, which is 3, here, which is 4, here, which is 5, here, which is 6. It's always one more than the number after the hooked together numbers, right? So we're going to multiply by 6. So it would technically be 2 factorial, 6 factorial, because 2 times 1 blast off. You get 2 factorial, and then 6, 5, 4, 3, 2, 1 blast off, so I can go 6 factorial over 2 factorial, 2 factorial, which should be 360. Then B is that standard of excellence question where I ask for you to put them where the vowels are not together. The only way I can do that is, yep.
Doing without any restrictions and then subtracting how many options you have with restrictions.
Right. So we want to get the opposites. So we do the word Trinity, no restrictions, right? The word Trinity, no restrictions is 7 letters, so 7 factorial divided by 2 factorial, 2 factorial. That's Trinity, no restrictions. Then I'm going to subtract off all the ways that the vowels are together, and what will be left over are all the cases where the vowels are not together, right? So I'm going to subtract 360 from here because I already did the vowels together. And what do you get as an answer? 500? 900. Close. 2 zeros at end point. Okay? Does that make sense? Okay, so you keep your quizzes because they're for you to study off of. So that's how you get directions on them, leave little notes for yourself, etc., etc. These are where you're learning. Because when it comes to the test, they get to see what you know. Yeah. Pardon? Not at this moment, but I can after. Okay, so can you flip to your notes, the old ones, because we're going to keep going off from where we were. Yeah. We're going to keep going off from where we were, and then we are going to move on to the new notes I gave you as well. So here we have Anne, Brian, Colin, Diane, and Eric go to watch a movie and sit in 5 adjacent seats. Adjacent seats means side by side by side, right? They're together. In how many ways can this be done if Brian sits next to Diane? So we do 1. No. Why are you not letting me write? So we have 5 blanks. And Brian has to sit next to Diane. So we hook them together. And we have 2 and 1. And then we have 3, 2, 1. And then what do we have to remember to do? Times it by? 4. Why?
Because there's 4 spots where they could sit next to each other.
Yep. Because they could be here, which is 1 way, or here 2, or here 3, or here 4. It's always one more than that. We wouldn't do this if they said sits together at the front, or if we said sits together at the middle, or if they said sits together at the end. We would not do that. So it's going to be 48. Anne refuses to sit next to Eric. That means that they cannot sit together. So what do you do when it says you cannot sit together? Total, no restrictions, minus them together, right? The total way you could sit 5 people with no restrictions is just 5 factorial. 5, 4, 3, 2, 1. And then we're going to subtract them sitting together. And sitting next to Eric is the same amount of ways as Brian sitting next to Diane, right? So I could just subtract off 48. I get 120 minus 48, which is 72. Number 5, determine the number of ways the letters in anteater. The moment I get anteater, I'm going to go A-N-T, E, A, T, E, R. Can be arranged if the word must begin with a consonant and end with a vowel. So anteater has 2, 4, 6, 8. How many consonants does it have? 4? I think it's 4. 4 consonants. A, and E, E. 3, 4, 5, 6, 7, 8. Yeah. 4 consonants. N, T, T, and R. And then 4 vowels. Right? How many letters have I left behind now, though? 2. How many do I have left? 6 for this blank. So I'm going to put 6 here then. 5 then. 4, 3, 2, 1, blast off. So if I can say 6, 5, 4, 3, 2, 1, blast off, I can say 6 factorial. And what am I going to times it by? Nope. 4 times 4, which is, yeah, 16. So what do we get?
Big number.
It is a big number. 720 times 16. Yeah.
So why don't you divide this one by the 2 factorial, 2 factorial?
You do. So what do we get as an answer?
11,501.
How much?
11,500.
This answer will be on your diploma. Right? It honestly gets picked more sometimes than the correct answer. Because people just get so excited to do the work that they forget to do what? Divide by the 2 factorial, the 2 factorial, the 2 factorial. So what did I say you should always do before you even attempt the question? Put the line and write that in brackets, right? Do it immediately so you don't forget, because they will have this as one of the answers, absolutely, and it's wrong. We have to remember to divide the whole thing by 2 factorial, 2 factorial. Divide this by 2 factorial, 2 factorial, which means I'm going to divide this by 2 factorial, 2 factorial. So what's that divided by 4? What's that?
33 though. 32.
Oh, yeah. Good save. Look, I can turn those brackets into 2's. This works out so well. So it's 11,520 divided by 6. 96? 96?
No, it's 14.
I'm like, there's no way.
It's 1,440.
Oh, it's divided by 8.
Yeah.
It's not divided by 6. It's divided by 8.
Yeah.
Is that nice?
Oh, never mind.
It's 1,440.
I just did what you did. I added them up instead of multiplying them, Maddie. I divided by 6 and 8.
You might have typed in 1,500.
Yeah, maybe. Let's do. The consonants must be together. 1, 2, 3, 4, 5, 6, 7, 8. Line. 2 factorial, 2 factorial, 2 factorial, which is 8. How many consonants are there? 4. So I'm going to go, I have 4 options for here, 3 options for here, 2 options for here, 1 for here. Then I have 4 blanks left, and I have 4 letters left. That's perfect. 4, 3, 2, 1. And then am I done? No, I have to multiply by 5 because it doesn't say together at the front. It says together. So I have to multiply by 5. So I'm going to get 4 factorial because 4, 3, 2, 1 blast off. Then 5, 4, 3, 2, 1. So 5 factorial. And then 2 factorial. 2 factorial. 360. Everyone type it in with that? Perfect. What's the catch with C?
The word must begin with T.
Must begin with T's. So I will have them together, but I'm not going to move them. right? No moving, because of the word begin. So I'm immediately going to go 2 factorial, 2 factorial, 2 factorial. 1, 2, 3, 4, 5, 6, 7, 8. There are 2 t's. I'm going to hook them together. So I have 2 options for this one. One of the t's gets left behind, and I have 1 left. How many letters have I used up? 2, and I have how many left? 6. So then I put a 6 here, leave them behind, 5 here, leave them behind, 4 here, leave them behind, 3, 2, 1, and I get 2 factorial, 6 factorial over 2 factorial, 2 factorial, 2 factorial. 180? Is it? Yeah. I just canceled the 2 factorials and then did 720 divided by 4. Okay. Smart human. Okay. The A's can't be together. So when we say the A's can't be together, we do all the ways we can rearrange anteater with no restrictions. It's always the easiest. It's going to be 8 factorial because there's 8 letters over 2 factorial, 2 factorial, 2 factorial. The way to rearrange a word when there is no restrictions is the easiest. It's just how many letters factorial over 2, 2, 2, because there's 2 T's, 2 A's, and 2 E's. Then I need to subtract off all the ways that the A's can be together. So we have 1, 2, 3, 4, 5, 6, 7, 8. I'd have 2 times 1, left 2 behind, and it's still allowed. 6 times 5 times 4 times 3 times 2 times 1. And then am I done? No, I actually need to multiply by 7 because the A's can move 7 spots, right? What does that get me? What's 8 factorial divided by 2, 2, 2, 2? What's 8 factorial divided by 8?
I have the final answer.
Okay,
Wait, were you talking to me?
sure.
3,780.
We can try it out. So we'd go alpha y equals enter. 8 math factorial divided by 8 minus alpha y equals enter 2 times 7 factorial divided by 8. You got it. 8? 2 times 2 times 2. I was just being lazy. All right. These little pathway questions. So for these pathway questions, I'm going to show you how I would legitimately do it as a pathway. Okay? I'm going to show you how I would do it as a pathway. They will never ask you to do it as a pathway ever. Ever, ever, ever. They will not be asked to do it as a pathway. But I'm going to show it to you as a pathway so that you trust that when we do it as a permutation, it actually works and why. Okay? So you're just going to pay attention to this. It says, if roots must always move closer to B, determine the roots from A to B. I'm just determining the roots from A to B. So if I went from A to B, I can't like go backwards, or else that would be an infinite amount of roots, right? I could just keep circling. So that's not going to happen. So all I can do is move closer to B. So I'm going to either be able to move down or right or down, right? That's all the only options I have. Down or right or down. That's it. or else I'm backtracking and making a circle again. So I'm going to count as a pathway. I would suggest you not write it this way because you're not going to have to. I'm just showing it to you so that you believe me when I tell you that you can find pathways using permutations. Okay? So to get here, I can walk right to here, or right to here, or right to here, or right to here. That's one path each. You don't have to show this part. So I can walk here one way, or walk here one way, or walk here one way, or walk here one way. I can literally just walk to it, right? I can't go here, go down, and then over and then back up, because I'm not allowed to go back up. That means I'm retreating. So I have one here and one here as well. I can just walk down, because all I can do is walk right or down. Now what I do is I total the paths as I go along. So if I have one path to get me here coming in and one path to get me here coming in, that's a total of 2 paths that could get me here, right? Then I have 2 paths coming in and 1 path coming in, so that's 3. 3 paths coming in, 1 path coming in, so 4. 4 paths coming in and 1, so 5. 1 path coming in and 2, so 3. 3 paths coming into here and 3, so 6. 6 and 4 coming in, so 10. And 10 and 5, so 15. So this one would technically have a total amount of 15 paths. I could take different paths, take me from A to B, walking down or right. Okay? Now, there has to be a better way, because this is not actually a permutation or a combination, so it's not in our curriculum to do it this way. So there has to be a way that we can fit it into our curriculum if they're going to ask this question. So what you do is you treat this like it's a down and a down. I technically have 2 downs that I could do, right? I can move however many rights, but I can only go down 2 times at some point. I'm also only going to be able to go over right 4 times. So what I can do instead of counting these paths is I can treat it like the word dir. D, D, R, 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 R is how I would stack the word, right? Technically. Now, how many ways could I arrange the word dir? No restrictions. On the bottom, we know we're going to have 2 factorial and 4 factorial because of the 4r, right? On the top, we would have how I could rearrange 6 letters with no restrictions. How could I arrange 6 letters with no restrictions? 6 factorial. Type that into your calculator. Remember, you want to type it in just because you want to make sure you're typing the name correctly. Did you get 15? So, the pathways method was literally for you to believe that when I tell you you can do this, you can get it correct. That's it. So it's fitted into this unit because of this, because of the doubling and tripling letters, because it's a permutation, because order matters, not because you can count pathways like I did. So you will never be asked to do it this way, right? Because that's not in the curriculum. You would do it this way. So for these ones, we're going to do this pathway separately, and we're going to do this pathway separately, and then we have to decide, are we going to multiply or divide, or multiply or add our answers? Well, multiplication goes with and, addition goes with or, right? So we have to decide, do I need these paths and these paths to get me to B, or could I just use these paths or these paths and get me to B? We need and or. And. Because if we only have or, we either have only one of these ones, and then we transfer in time to get to B, right? That doesn't make sense. So it's an and. So if it's an and, we need to do what? Remember, and add sound like best friends? But they're so close that they hate each other. Just dislike each other greatly. So, multiply. So this one we have D, 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 R, 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 R. So we do that one first. So what's this one going to represent? How many letters are there? 8 factorial divided by 4 factorial, 4 factorial. Then we said we multiply them because we need an and. Then this one we have D, D, R, 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 which is how many letters? 5 factorial divided by 2 factorial, 3 factorial. Type that one in. 700. Did I really need to write the 1 factorial on the bottom?
No.
No. Could every single example actually have 1 factorial on the bottom?
Yeah.
For sure. Yeah. Did it make sense? Did you figure it out?
Well, like, how are they doing the pass? It's like one block and one pass.
No, the actual outsides of the paths.
Yeah, so then how many passes?
So this would be 1 to this corner and 1 to the, I should not be using black, you can't even see it. 1 to this corner and 1 to this corner, so that would get me 2 to that corner, right?
Yes, sir.
Yeah, and then I'd have 2, 2, 2, 2, so I'd have 4, 6, 6, 12, 12, 12. I'm gonna go battery, 36, 36, 72, 48. Oh my goodness, 120. 60, 180? Is the answer 180? Please tell me the answer for me.
Good job.
We used to do pathways in 30 applied. Like this used to be an actual like lesson in 30 applied. The old signal. Okay. So permutations, order matters. Okay? So where does order matter? Order matters when you're doing postal codes, when you're doing telephone numbers, when you're doing arranging people in a photo, when you're arranging books on a shelf, when you're arranging anything, order matters. Digit numbers, order matters. Codes, order matters. If I had a group like this class and I wanted to pick a president, a secretary, and a treasurer for this class, I would take one person off of the list and I would do 18C or 18P3 because I was giving you guys specific jobs, right? Specific jobs for the class. So if I give you specific jobs and I pick that small group, it's a P. But say I wanted to just form a 3-person committee. If you were picked first, second, or third, would it matter? No, because you'd be on the committee or you wouldn't. So that would be a combination. So that would be a C.
Did you do that?
Not quite.
It's
All right.
democracy.
It is a democracy in some ways. All right. So our curriculum for this one is solve problems that involve combinations. It's our last lesson. We're not going to be done it today, but this is the last thing we're going to do. So combinations is a selection of elements in which the order of the section is not taken into account. So determine when order matters. So we have a committee of 9 people chooses 3 people. Now, stupid Crystal in grade 12, and I'm saying stupid Crystal in grade 12 because that was me. I cut myself down. Stupid Crystal in grade 12 did not understand perms and comps. Like, I did not understand what was a perm and what was a comp, and that was a real problem because you're 50-50 guessing whether you use a P or a C, and that is never a good place to be. It's a really bad place to be, actually. So what I didn't realize is in order to decide if it's a permutation or a combination, you have to look at the people that you're choosing. Does their order matter? Not the total amount of people, just the people you're choosing. So if I go here and I say a committee of 9 people chooses 3 people, so it's those 3 people I'm going to look at. Okay? Now I got to keep reading. I'm looking at those 3 people. And I'm going to choose those 3 people to be a president, a vice president, and a secretary. So I look at those 3 people. Does the order in which I pick those 3 people have a different outcome? Yeah. They could be president, vice president, or secretary, right? They have 3 different outcomes that they could get. If the 3 people have 3 different outcomes, order matters because they could get 3 different things. Okay? So that would be a P. So for this question, I would do 9p3. It's permutation. So you type that one in, 9p3, give me an answer.
I look for it.
504. So there's 504 different subcommittees I could make, arranging them president, vice president, secretary with those 3 people. Okay? If I have a committee of 9 people chooses 3 to form a 3-person subcommittee, I look at those 3 people. They're forming a 3-person subcommittee. Are they any different if they're picked first, second, or third?
No.
Do they have jobs or positions or anything?
No.
No. So order doesn't matter. So when it's just a 3-person subcommittee and you can say I'm on the committee or I'm not, I get to go to the go on the trip or I don't. If that's the only option, you either get to go or you don't, then that 3 people that you're choosing, the order doesn't matter. They either get to go or they don't. You either get to be those 3 or you don't, right? So the top 3 had actual positions and jobs. So that's a P. The bottom 3 doesn't. So that's going to be a C. So we're going to do 9C3, which means the order doesn't matter in which I pick those 3, which really drops the amounts. So we're going to go 9 math over to probability and pick number 3 this time. 84.
That's amazing.
So there's substantially less cases if the order doesn't matter, right? Because we're not arranging them. Okay. We're going to look at example 1. A student must sign out 3 different books at the library to read for English class. She has always returned her books on time, so she's allowed to take all 3 books out at once. How many ways can she do this? How many different ways? She needs to take out 3 books. She can go in one way. She literally walks in, she says, here's my 3 books. They check them all out. She gets her 3 books. She leaves, right? One way. Because it's 3, how many I have to choose from? 3. And C, because order doesn't matter, because I'm taking them all at once, 3, which is 1.
Wait, what's the second 34?
She's choosing 3 books.
So it's
She has 3 books and she's choosing 3 books.
Wait, is that the same as like, with P where if you take away one, it doesn't make a difference to the 3C2, or is it make a difference?
No, it makes a difference.
Okay.
Yeah.
It's just with P, that's.
Yeah. Okay, so then this one says, another student must sign 3 different books out of the library to read for her English class. She is in bad standing with the library and can only take one book out at once. How many different ways can she take out a book? Now does the order matter? So she's taking out 1, so that one has 3 options for that first month, then 2 for the next month, then 1. So I could go 3, 2, 1, or I could go 3P3, which is actually 6. Because 3P3 stands for, I have 3 blanks, right? That's what that 3 is. 3 blanks, and I start at the number 3. 3, 2, 1, which is 6. No. Okay, this is the formula that you use for NCR. So NPR looks very similar. NPR equals n factorial over, and this is in the new booklet, n factorial over n minus r factorial. That's NPR, and it's on your formula sheet. And CR, however, is n factorial over n minus r factorial r factorial. So the only difference is this r factorial. When do we put a number factorial in the bottom? When have we done that in the past? If there was repetition, it got rid of the repetitions, right? So why are we doing that between a perm and a com? Permutation order matters. Combination is the permutation taking away the order. So that's why we're dividing the r factorial. It's getting rid of all those doubles and triples in different cases because we don't care, right? Because order doesn't matter. Something to note about combinations. They can be written like this. So in the previous one, let's just say we had 6 books and we could take out 3. We could go to the library and just take out 3, right? Or it wouldn't matter on those 3, would it? So we could say, well, not take out 3, we'll take out 4. So say we have 6C4. We're taking out 4 books. I have an option of 6. I go to the library and I take out 4. So the order in which I pick those 4 out doesn't matter because I just take them and I put them in my backpack, right? Only with C. This does not work with P. This equals 6C2. And I'll show you why. So what's the difference between 6 and 4? Difference meaning subtraction. 2. What's the difference between 6 and 2? 4. So if you take the difference between them, they'll actually equal. And I'm going to show you why because I'm going to plug it into the formula. In the formula, this is N and this is R, right? And I told you that N has to be what R? N can be bigger than R, and N can be the same as R, but cannot be smaller. Exactly. So N has to be greater than or equal to R. We agree with that. Now if I fill this into the formula, this is my formula here. I'm going to go 6 factorial over 6 minus 4 factorial. 4 factorial. And if I fill this into the formula, I'm going to get 6 factorial over 6 minus 2 factorial, 2 factorial. If I reduce this one, it's 6 factorial over 2 factorial, 4 factorial. And this one is 6 factorial over 4 factorial, 2 factorial. Does that make any difference? 2 times 2 factorial times 4 factorial or 4 factorial times 2? No. Multiplication can be in either order. Like 3 times 4 is the same as 4 times 3, right? So it only works because of the difference, because there's this extra r factorial, which P doesn't have. So you can't go 6P4 equals 6P2. That's not true. It only works with C's. So if the answer, say I went to the library and there was 20 books I could choose from, and I was picking 3 out and putting them in my backpack and going home, right? And I would say 20C3 would be my answer. Or say I had a group of 20 and I was picking a 3-person subcommittee, right? That's it, 3-person subcommittee, no jobs. Then it would be 20C3, right? What could they put as an answer on your diploma though? Not 20C3, what could they put? 20C. The difference between the two. What's the difference? What's 20 minus 3? 17. 20C17 is the same answer as 20C3. So if I gave you 20C15, that would equal 20C what? 5. Can't, same answer. The other thing with a C, and it's on your formula sheet right here. Woo, just what died. I should go for a second there, but I made it. NCR equals N over R, right? They can write it like that. So instead of writing 20C3 like this, you could see this on your diploma. And that means C. Because it's told on your formula sheet. It's also on the 30-1 formula sheet. That 20C3 can be written as 20 and then 3, and that means C. If you forget, it's on your formula sheet, right? Like if you see this and you're like, I remember saying something like this, go to your formula sheet and you'll see, oh, it's a C. Yeah. You're going to get a separate formula sheet to keep, and then on your unit test, you'll also get a separate formula sheet. I just have to buy the plastic folders to put the thing in, and I haven't gotten anywhere because I don't shop anymore. It's like COVID hit, and I'm like, I shop online or I don't shop. That's what I do. It's really weird. Okay, I didn't say pack up.
I'm just guessing.
No, don't guess.
Too many minutes.
10?
No.
Okay. It's 36. Then it's 46. Then it's 19. Okay. We literally have one question left. Let's just do the question.
We gotta clean up.
We have to clean the desk.
No, shush. Okay.
Safety.
Safety first.
Well, you're going to. You don't need 15 minutes to clean it. So, shh. You need to take some time out. So, 3 students from a class. I used to like you. 3 students from a class of 10 are to be chosen to go on a school trip. So 3 students from a group of 10. They're going on a school trip. Does the order matter? Did you give those people jobs on that trip? No. So we're going to go 10.
C.
It's as if I did not just speak for half an hour. 10C3, which could be written as 10C7, which could be written as
10C3.
like that, which could be written as
10C7.
which could be written like that.